This video deals with the difference of two squares, where difference refers to the subtraction of a term from another term, and squares refers to square numbers like 3 squared, 4 squared, 5 squared. So numbers of the form a squared. And to illustrate the concept, we're going to expand the following expression. So we've done expansion, and we're going to apply the principle of expansion to this expression. Expanding gives the following. Take the first term inside the first bracketed expression, multiply it by the second bracketed expression. Note the sign after the term, which is the first term in the first bracketed expression, and take the second term in the first bracketed expression and multiply it by the second bracketed expression. And then we expand each of these terms, and this gives the following. So first term outside times first term inside gives a squared, note in the sign, plus term outside times second term inside the bracket gives ab, note in the sign. And it's always safe to do this, put a bracket outside, especially when you have a minus before a bunch of terms. So we have first term outside times first term inside, which gives ba, which is the same thing as ab, note in the sign, plus, and first term outside the bracketed expression times the second term within the bracketed expression is b squared. So we have a squared plus ab, minus times ab is minus ab, minus times plus b squared is minus b squared. So this gives a squared. So ab minus ab is 0, so this cancels out. So we have a squared minus b squared. So then just say that again, plus ab minus ab is 0. So I should also cancel the plus, which leaves a squared and minus b squared. So we have a squared minus b squared. So the expression a minus b into a plus b, or a minus b times open bracket a plus b close bracket is equal to a squared minus b squared. And this is the crux of the difference of two squares. So the whole idea of the difference of two squares revolves around the expression highlighted here. It says that an expression of the form open bracket a minus b close bracket open bracket a plus b close bracket is equal to a squared minus b squared. That means this expression can be simplified to give a squared minus b squared, or in other words, a squared minus b squared is a minus b times a plus b. And these expressions, this one or this one, because they're the same thing, call this one prime, are very useful when you want to simplify expressions, as you find out shortly. Just the key thing to notice, this expression is the underlying concept behind the difference of two squares. And as I mentioned earlier, a square number is a number of the form a squared. Numbers like, so when a is 2, we have 2 squared, a is 3, we have 3 squared, a is 4, we have 4 squared, and a is 5, so 5 squared. So numbers of this form, a squared, are square numbers, or numbers that can be written in this form. For instance, the number 4 is a square number because the number 4 is actually 2 squared. The number 9 is actually a square number because it is actually 3 squared. 3 squared is 9. The number 16 is also a square number because it can be written in this form 4 squared, which is of the form a squared. Also, the number 25 is a square number because it can be written in this form as 5 squared. So a square number is a number of this form, or a number that can be written in this form. So take note of that. And now we're going to use this either of these equations to simplify algebraic expressions. One more thing to highlight before moving on is that the expression a squared minus b squared is an expression that is the difference of two squares, where a squared is one of the squares and b squared is the other square, and we have the difference of two squares. You remember, difference has to do with the subtraction of a term from another term. Here we have the subtraction of a square term from another square term, hence the name difference of two squares. And anytime you have an expression of this form, you can write it in this form, or vice versa. You can start from here and get here, or start from here and get here. So now to example. Now we're going to use the difference of two squares formula, which is here, to simplify some algebraic expressions. So here's the first one. we have the expression x minus 7 times x plus 7, which is of the form a minus b times a plus b. Now, as you can see in this case, a is clearly x, and b here is clearly 7. So we have something that's a minus b times a plus b. So if I write it in this form, we clearly have, it's very obvious. Now, a minus b, x is a, b is 7. So we have something of this form. The result is a squared minus b squared. So we have a squared minus b squared. What's a squared? X squared. What's b squared? 7 squared. So we have x squared minus 7 squared, which is 49. And this is the result of the simplification. Here's another expression. Now, as you can see, this expression is of this form, a squared minus b squared. It's of the form a squared minus b squared. And you know that a squared minus b squared is equal to a minus b times a plus b. So from this expression, we can see that our a is 6, and our b is 2. Therefore, 6 squared minus 2 squared must be equal to a minus b, which is 6 minus 2, times a plus b, which is 6 plus 2. 6 minus 2 is 4. 6 plus 2 is 8. So what we have is 4 times 8, which is 32 as our result. So this expression is equal to, simplifying using, we just basically simplified it using the difference of 2 squares formula, and we got 32. An alternative approach would have been to say, well, 6 squared is 36, and 2 squared is 4. So 6 squared minus 2 squared is the same thing as 36 minus 4, which is equal to 32. I'm just showing you that the difference of 2 squares formula can be applied to an expression of this form. Sometimes you might have an expression like, let's move to this one. 49.5 squared minus 1.5 squared. Now, you don't know what 49.5 squared is by heart. Most people don't anyway. So instead of getting a calculator and squaring this term, multiplying this number by itself, then subtracting the result of 1.5 times 1.5, you just say, well, this expression is of the form a squared minus b squared, where a is 49.5 and b is 1.5. We know that a squared minus b squared is a minus b times a plus b. Therefore, 49.5 squared minus 1.5 squared is actually equal to our a minus b, our b, 49.5 minus 1.5 times our a plus our b, 49.5 plus 1.5. And this simplifies to give 48 times 51, which we can then use a calculator to determine as 2,448. Now, it would have been much more complicated if we were squaring this number and then subtracting the square of this 1.5. The formula for the difference of 2 squares simplified this problem, even though we had to use a calculator at the end. But you could have multiplied this out as well using the long multiplication approach. Here's an expression, and if you're asked to simplify such an expression using the difference of 2 squares formula, you need to observe or be able to note that 49 is actually the same thing as 7 squared. So 49 is a square number, 7 squared. So this expression is this, is equal to this. Now, this expression is of the form a squared minus b squared, so the form a squared minus b squared, where a is clearly 7 and b is x. And you know that expression of the form a squared minus b squared can be written as a minus b times a plus b. Therefore, 7 squared minus x squared can be written as 7 minus x, because a minus b, a is 7, b is x, times a plus b, 7 plus x. And we're done. So this really isn't a simplification, this is more of an expansion. The whole essence of this problem was to apply the difference of 2 squares formula to this expression. So this is really a simplification, because this term is more complicated than this simpler term.